Hello, welcome to our podcast Stack More Layers. Today I will be talking with Barbara Rychalska.
Hello.
And my name is Maria Janicka. We are both AI researchers at Synerise. So the topic of our conversation today is Yann LeCun's vision of AI development, or the way to general artificial intelligence, maybe. Maybe I'll start by saying who Yann LeCun is. He is a Silver Professor at NYU University. He is Head of AI and Vice President at Meta. And he's also a Turing Award winner, and he's also called the godfather of deep learning. So one of the pioneers.
Yeah. A legend in the field.
Yeah, definitely.
If someone doesn't know them, it would be strange.
Yeah, definitely. So I think that his proposal is something that it's worth discussing and having in mind and looking deeper into. But maybe to start with, I will refer to his cake analogy. Because some time ago, this is this famous in the world of AI analogy, where he mapped different parts of a cake to different fields of AI. On the base, the cake itself, for him, is self-supervised learning. Supervised learning is the icing, and reinforcement learning is the cherry on top. So it was somehow controversial because, cherry on top is something that is really something extra and definitely not essential, while other researchers claimed that maybe reinforcement learning is the way to general artificial intelligence and should be the path of further development. So how do you feel about it?
Well, for sure, reinforcement learning has some great expectations. And we've seen a lot of success there. For example, the famous Go players, artificial intelligence players were reinforcement learning models. There are very successful artificial intelligence models based on reinforcement learning in all kinds of games. Autonomous vehicles, it's also the same story. So they are considered to be major research direction there. And a lot of hope is put into them, that they will finally give us really autonomous, very smart and safe self-driving vehicles. However, I think that LeCun is kind of addressing the fear that we might have. The fear is that there's been a lot of promise, for example, regarding the self-driving cars. And still, they are not out there, right? They are not roaming our streets in massive numbers, as we have hoped. So it's really cool that someone, just when you go and you hit the wall, in a way, you just need to find another venue, right? So that's what he's proposing. He's proposing that maybe this path is not the path. So let's look at others. And he has very reasonable doubts about reinforcement learning.
So one argument is that people or even animals learn skills rather fast, new skills. His very often repeated example is that we can learn to drive car in 20 days, let's say.
Yeah.
And for reinforcement learning system, it's infeasible. It
hasn't still happened yet to this day, and they have a lot more data. Like they have the data from thousands of drivers, and including the hardest cases that can appear, and still they cannot learn to drive at the level of a human driver. In terms of safety, like this general common sense on the road, so to say, So these drivers, the artificial drivers, can be surprised by all kinds of weird stuff, like, I don't know, there is snow or there is a sign that's not fully in light or partly in shadow or something like that, and they can really be tricked into this, like that they behave really wrong when there is something happens which is entirely easy for a human to solve.
Yeah, and I think that one of the arguments is that it needs very much, a lot of trials to learn a new skill.
Yeah.
While it isn't like that with human intelligence. So
Yes.
maybe that there is a way to do this more efficiently.
Yeah, definitely. Because in reinforcement learning, there is this agent that learns, and the agents are interacting with an environment somehow. And the environment has some inherent logic, which results in the agent receiving rewards for its actions. So usually it's like the agents that start interacting with the environment have no knowledge whatsoever what this is and what the goals are. So the task that as humans or trainers of these algorithms know are, for example, some game when you need to hit a ball. There is a ball coming at you and you just need to hit it so you don't get smashed in the head, for example. So the first thing that such an algorithm could do is like simply do nothing and get hit. Then it will just lift the hand in some random way and still get hit. And then after thousands and thousands or millions of trials, finally the agents are able to figure out the environment. However, in humans, when there is this another famous case of LeCun's examples is with babies, that he says, well, babies learn to walk a lot faster and with less data than a reinforcement learning agent would do. And indeed, I really think that he has a lot of merit here, because think about how the reinforcement learning models learn. They fail all the time, and there is no inherent cost to this failure because we can just rerun them again. However, in the real world, if a child was learning to walk and it would just fall each time it fails, it would be just too dangerous. Simply the cost is too high for this to work in real life.
Yeah, and I think
there's a lot of negative feedback in reinforcement learning, and the cost of doing it wrong in real life is extremely high.
Yeah, and I also think that there is a claim by Yann LeCun that child in the first few months learn a lot of grand knowledge, mainly by observation.
Yeah.
It's a strong statement, and if you think about it, yes, there is not a lot of interaction with the environment. The interaction is limited for this few months old child, and there is no language, and so the observation, in fact, is the source of the knowledge. And he even hypothesized that that from this grand knowledge is where the common sense arises. So it is very against the idea of reinforcement learning, which is through acting in an environment when you get the knowledge and about the environment.
Yeah, definitely with children, it is first about observation. And there is no way for the child to get a reward, be it positive or negative, right? And this is also the case where I think it's worth mentioning this interest that LeCun has in self-supervised learning, because there is where he sees the option to kind of emulate this child learning scheme. Because self-supervised learning as in his papers, he's worked on them for quite a long time. There is a branch of research that does this kind of learning without negative examples, so without contrastive learning. So this shows that we can, in fact, learn without being said what you are doing wrong. Like when you, as a child, you learn to identify some kind of animal, you are shown that, well, this is an elephant, and this is also an elephant. However, you do not have to be shown non-elephants at the same time in order to learn elephant, the concept of elephant.
Maybe we'll start by explaining what self-supervised learning is, because we just focus on this reinforcement learning part. And there are two other parts. There is supervised learning, that was this cake icing, so also not like the most important part. And supervised learning is when you have the set of data with grant truth label. So when you want to train model to solve a given task, you show what is the answer, how to solve the task. So you have, for example, if you want to train AI algorithm to, I don't know, categorize news articles. So you, in supervised learning, you show to the model the annotated data. So you have some piece of text and the label, if it's sport, news, weather, and so on.
And there is, of course, the problem of labeling, right? Because someone must do it, and you need to provide high-quality examples of what is your class and what your class isn't, like what is a news or what is not news article, right? So this is a very big problem right now, because the cost of annotation is high. So you need to just put people in there and tell them to annotate millions of images, for example. Because the models that currently that are currently created, they train on massive amounts of data. For example, the whole internet, the whole Wikipedia, right? So this is the scale of data we are dealing with.
So it's one more time is this is the problem, that we need a lot of data. As in reinforcement learning, we needed a lot of trials. Here we need a lot of annotated data, and we can obtain this data, I don't know, from somewhere, but the quality of data needs to be very good in order to train a good model, because the model is only as good as in supervised learning as the data. So that's an issue, and annotated data is a lot of work to create this like human curated data set. So there are a lot of issues with supervised learning. So, but what about self-supervised learning?
So self-supervised learning is the king recently, and it's about like discarding this whole notion of targets and annotation by humans, and it is about simply predicting something from the data that we have which isn't labeled. For example, it is in natural language processing, when we learn the word embeddings, we learn to ingest like one part of a sentence and predict what's in the other part of the sentence or the next word, for example. So we just get a raw text. We don't have to pre-process them in any way. We just try to capture the idea that usually when you're talking about something in a sentence, your next word or next part of the sentence belongs to some topic, for example, or is based on grammar. So you require a certain part of speech after you've said a noun in a given phrase. So this is a really cool place for learning the meaning of words, for example, and the recently popular models such as GPT, for example, they are based on self-supervised learning. So in fact, this proves to be really successful solution to the learning problem. And there is another sub-branch of this self-supervised learning thing, and that is something that LeCun works on, and it focuses on learning representations. They strive to be able to, for example, express a state of the world, as LeCun states in his JEPA paper that
Yes,
will
so
be
maybe
transition. Maybe I just mention it briefly and then we just go over
okay.
it. So the idea is to learn a representation of the current state of the world of a word meaning, or maybe about the meaning of a given image. So representational learning. And LeCun is also very excited about this self-supervised learning without contrastive learning. So the fact that you can have learning which never has any negative examples. And this is something that appeared in this famous paper, Bootstrap Your Own Latent, latent, where you have mirrored networks. One is a weighted average of some previous steps of the original network. And the other way is just the original network, which is just a network that trains. And then you modify your given image in two ways, and you put the same image, only modified in two different ways, into the origin network and this weighted average network. And some magic happens that you are then able to derive meaningful representations. Although you have almost the same networks, and you have the same image that gets put through these networks, there is no negative example, like what this image isn't. You just see what it is, and it doesn't collapse. There isn't this famous problem when you just run the same thing through kind of the same network. You can just end up with a constant representation, because this network will just know that it's always the same. So it will just stop training. However, these guys could make it work, and LeCun has also made progress in this area. And this is something he believes in.
Yeah, I think that we covered a lot of different topics here. So, first of all, this supervised learning is the type of learning where you look for some relations inherent in data. So you don't need annotation. You can use just plain text, and model is training relations between words to cover words meaning, and that was the GPT-3 example. And the other thing is, because maybe I would at this point introduce the main player here, which is JEPA architecture. Maybe not, but we want to talk about this idea by Yann LeCun, because he proposed this kind of end-to-end modular architecture that he believes is the future of AI. So there is this famous picture with the graphical representation of a brain and different sub modules of LeCun's proposal in this very colorful circles mapped to different regions of a brain, very roughly mapped. This is, I don't know, I find it very funny, this graphic. But he shows different modules of his architecture. And there is perception models, so that's how we collect the knowledge about environments. So for example, for human it will be through our senses, so what we see and so on. And there is word model module. I think it's very important, and we will cover it in more details. There is cost, and there is an actor who is who is responsible for the actions, so acting in the environment. So like perception model, it's collecting the knowledge about the environment through senses, for example, or for artificial intelligence through sensors, I don't know. And word model is creating the representation of a word, a latent representation, so representing some important aspects of a word from the perception model, some important aspects that can be used to plan actions and or to predict next states, and through this prediction of the next states, he can plan action. And a cost module is used to get to assess the cost of the action. So in order to decide which action to take, we need to have some information how much will it cost us, and to decide what is the better plan. So the plan is done in this latent representation in the word module, and the cost is telling us which we need to minimize the cost. And
it's like a dissatisfaction of the actor.
Yes.
Yes, so definitely his approach about having these modules that roughly mimic what we know about the brain. We know that various parts of the brain have various functions, although they can also take over functions when some part of the brain is damaged. So it's not like set in stone that you need to use your back of your brain for your vision or something like that. But still they get specialized. And it's not, I think it's not common for models, deep learning models, to have such a large amount of submodules that are interconnected and influence each other in various ways. We do have a lot of things where we have attention and some pre-processing before attention is computed and so on and so forth. Generally, they are like arranged in a stream of processing. So they are just, one after the other. There are various phases of processing. However, with LeCun, it's a brain is interconnected, and various parts do configure the behavior of others. Like there is also this the super module that is kind of supervising everything, and I think this one is really not described very well.
Yeah, I think that LeCun even said that he's not sure how the controller should work, but something needs to coordinate the work of other models. Yeah. So from what you've said is I can infer that one novelty of LeCun's approach is this modularity.
I think so. Although there is some degree of modularity already, but I think it's put to a larger degree in his vision. And the one part that is most researched and sort of ready, maybe, is the word model. And indeed, this is where he puts his background in non-contrastive learning to use. So this word model is expected to be able to tell whether a given projection in time is viable or not. So we learn with this module, we could learn to make predictions of the next state of the world, about what is possible right now, given some hidden conditions that are expressed in terms of a special vector. We learn without negative examples, obviously, what's going to happen, basically. And this is where he uses ideas from his previous works, like the Barlow twins paper, for example, to again prevent this learning from collapsing. Like I said before, that these models tend to collapse and learn like constant representation. However, it has been, like this step has been made and they have been made to train. We know how to do it. And he's using this, this knowledge right now. So he doesn't need for people to experiment with environment and get the rewards from environment and get the negative feedback.
I think that a good example of what you are telling will be, I don't know, maybe based on the situation we are in. So there are several possible continuation of the situation. We can talk some more, I don't know, I can stand up and go out, but it's rather not very possible that something will flow, like fall down from, from the ceiling or float, or there are more possible next actions or next frames of reality, and less possible. And in contrastive methods, we train model by providing this more possible continuations and this less possible continuations, and telling the model, okay, this is possible and the continuation, and this continuation is rather not good continuation of this situation, and the model, this is contrastive training, and here we want to have only the actual continuation of the situation to train model, but we don't want the model to represent only this one continuation, because it won't be able to generalize, but to have like the broader area of possible continuation. So the collapse will be if the representation will fall down to this one particular continuation. So that's the collapse which we want to avoid, and which is not so, it's hard to do.
The collapse is also producing meaningless representations. So they are not even, they are like not there is not one viable representation, but the one that we get is meaningless. So this is a big problem, generally, this collapse. And there's also another argument that he's making against supervised learning regarding the dimensionality of the embeddings that he wants to get, so the representations of the world that we want to get. So we want them to be really big in terms of dimensionalities. So obviously we, in deep learning, we're usually dealing with very high dimensionalities, like on the scale of thousands. So imagine we are now in 3D and you then get transported to something which has 2000 dimensions, right? So there is a lot of problems connected to this, and one that LeCun wants to avoid is that when you try to generate good examples, like negatives in this case, in a very high dimensional space, you just get blown away because you need to generate an incredible number of good examples to cover this whole huge space. And this is related to this dimensionality curse that we often talk in machine learning. So that when you increase the dimensionality, your problem just blows up. You know, it doesn't get like 2 times worse, but it just gets a lot more worse.
Yes.
So so this is why he doesn't like supervised learning. Next to the other problems that we already covered, like the fact that you cannot really generate meaningful negatives because you don't know which are just right, because you cannot have, like, you can have negatives which are too easy for a model. You can have ones that are too hard. You just need to kind of hit the right spot in this case. So it's just better to not have them if we can.
So what we know about LeCun's proposal is that it's based on self-supervised learning, and he avoids using contrastive methods. And what else? What kind of new approach, or maybe what else it is to this word model architecture or JEPA architecture, because it's joint embedding
That's a good question.
JEPA, joint embedding prediction architecture. Okay, sorry, it's JEPA.
Let's just settle on JEPA. Yes, so another thing that is important in his vision is that he takes a lot of care to include other knowledge about our cognitive mechanisms, and he's including both systems of Kahneman, so the system 1 and system 2. So system 1 is something that works when we just behave impulsively or out of intuition. So we don't generally delve too much into a task, and we just work on impulse using some heuristics that we have. And they are often wrong, obviously, and that's what Kahneman proved in his book. And the other system is the system 2, which is concerned with conscientious like reasoning and thinking and planning. So he's including them in his vision, and he has this like diagrams of models about displaying each of these systems and showing that they indeed fit into this scheme of his. And this indeed shows that he really wants to emulate human thinking. Like he really wants to have this, like the system 1 even, which is kind of a bit like criticized in Kahneman's book, I think, because it's like a shortcut in our cognition. So it leads us to making a lot of mistakes.
But as I believe, he also refers, because he's using terminology mode 1 and mode 2, and in this mode 1, he referred also to the actions that we do unconsciously, which are in a lot of time like the very needed heuristic. So we do not have to, brush our teeth consciously, because we do it automatic. And with this car driving example, where at first you are very focused and very conscious of what you do when you are learning to drive a car, and after some time it becomes it's automated. And I think that there is the idea in LeCun's proposal how to from this mode 2, so actions that needs planning, reasoning, and some conscious thinking about what to do. You can go to mode 1, so this unconscious actions. I don't know if we'll cover it here, but I think it's worth mentioning that he took it into consideration, that some actions that needs to be first trained somehow in this mode 2 are then transferred to mode 1 and doing it unconsciously.
Yeah, I think that's what he probably means, that you just can automate something and it's not worth kind of your consideration when you're doing it. However, I don't know if it's valid for a machine learning model, right? Because with human brain, there is this problem of processing power generally. And we cannot expand our minds at all. We just have the number of neurons that we can grow in our brains, and that's all. We don't have a lot of capacity. And there are many hypotheses why this system 1 actually works, and why do we have these errors in our thinking. And some theories say that it's because we simply have to spare computational power. Yeah. So maybe it's not like we need to emulate everything from our brain in this artificial intelligence model, because it can simply like not have these same problems that we have.
Yeah, that's interesting point. Yeah, that's interesting. So
there's also this conception that we might have a brain which is inherently built to perform certain functions that are not like higher cognitive functions, but they are motor functions and basic survival. And because our architecture was evolved into this, and the higher thinking evolved much later, the basic design is like hard to change. So the higher cognitive functions can just appear on top of that. And the whole structure is not geared towards these higher cognitive functions. So it might be inefficient in a way.
So what you are trying to say is that we may think of artificial intelligence or designing artificial intelligence in the way that will avoid our flaws, which is connected with that we need to somehow manage our fleshy bodies in the environment, and it's like a lot of our computational powers.
Obviously, I don't suppose that we can just do it as reinforcement learning does, because reinforcement learning like puts us at the start of evolution, and we need to discover everything from scratch, so to say, right? However, with LeCun's idea, we can exploit the knowledge that we have about humans and just skip this whole, phase of like creating this mind during evolution, and just use this blueprint for our next step in AI, so to say. So I generally think that it's worthwhile to just use the best design that we have, and it is our brain that has been worked for enormous time by evolution, worth taking into account. However, I don't think that human thinking is like the best that we can have. It's easy to prove that humans are terrible, and also like Kahneman's saying a lot about this. That humans take incredible effort to compute things in memory, for example, like do computations on numbers. And we cannot really see a lot in numbers when they are abstract. We need to see like vision, like visualizations. This is why we have, this is why we visualize stuff simply, like we draw diagrams and so on, because we do not see patterns in numbers.
And that's why we are using artificial intelligence, or to just look for patterns in numbers. That's where we are not so good, but where artificial intelligence can step in and
exactly. So this is what I'm thinking about my work, in our work in Synerize. Because we work with big data, and that's usually abstract in nature. So they are just some behaviors of users over time. There are, like features of products, like prices, and some code names that you don't even know what they mean. And sometimes, no one knows what they mean, because they've been created some time ago in the data, and they are just there. You don't know what they are. They are just some numbers or names, abstract names. And this is why I actually kind of see a contrast between what we need to do with these streams and what people, for example, working in healthcare need to do, because they have some recorded like monitor data from like heartbeats and blood pressure and whatnot, only numerical, right? Impossible to understand for humans easily. And the works on the human-centered abilities, they are on the second part of this picture. So like generating music, generating images, generating language. There humans can be seen as masters, as nothing better than a human, right? When it's about paintings or essays. So there we are the gold standard, for sure. But in many other areas that need to be solved, humans are far from perfect design. So this is what I'm thinking, when I see that he wants to emulate all the whole structure of human brain. There is this thought that maybe it's not the perfect structure after all.
Okay, so because I
kinds of tasks.
I was thinking if if the structure will be an issue, or just if we emulate a structure without these constraints or on a computational power or different constraints, maybe it will ward away. You say, I don't know if I think that I'm not sure if the idea, if LeCun's idea is lean towards some of these two things. So AI mimicking human skills, or AI that is doing stuff that we are not the best in. So like creating intelligence that is skilled in areas that we are not skilled in. Yeah, so I think that I don't know if I think like for now, for this, because the important thing is that it's a vision, it's an idea, and it's not some kind of proposal for further development, not the practical solution to use now. So yeah. So I think
I actually think that he wants to develop this further. Like he wants this because as far as we know, it is not implemented yet in any way.
Yeah.
So. And I saw an article on Facebook's page when they say, wow, we've kind of done this for the first time and we just shown you the vision instead of giving you the result. So they, it's cool. I think it's cool. They indeed gave this first thought that usually just hide away in your lab when you just want to implement this and put it out.
Okay, so I think the interesting question will be how do you believe it will influence AI research? So will researchers now take this blueprint and I don't know, and this brain picture with this circles in paint, and okay, so now I will do perception module.
I don't know if they could do them in isolation. Maybe it wouldn't make sense to just make them in isolation, right? Because what would be the result?
Yeah.
But yeah, I think it's definitely possible that he put the vision out there, and someone will step in 2 weeks, for example, and reveal that they made an implementation of this of some form, and they have results, and the results are great, for example. Yeah, so then he would suffer something probably, but he doesn't care. I think that the guys who made this working implementation could get a lot of kind of reward in the scientific world for this.
Do you think that this is because he do not believe that it is it will happen immediately? So because I can imagine that if you are drawing this vision that is a vision for some time horizon, it's not that you are selling your good ideas that you can implement right now and make profit like intellectual or any other from it.
I think he's had so much success already that he is not after citations anymore. I think he's on this level when he's like one of the gods of AI. It's hardly anyone in the world who got like more credit than him and Bengio and Hinton, maybe this kind of guys. But they are just few guys, and there is no one better than him. So this is when he has. I think he's on a mission to do it for science, I would say.
Yeah, I think he is the person to set the tone for the future research, and it taking into consideration some kind of scientific calling or mission, and it is value in itself.
If you want to attack a very well-established branch like reinforcement learning, it takes a lot of courage, and you need to be a really respected person in order to be taken seriously.
Yeah, of course.
Because I think like this Silver, right, and this guy who wrote this paper, reward is enough, and Sutton also, they are from DeepMind, and after AlphaGo and AlphaZero, they've proven that indeed, reinforcement learning, there is something in it, right? So when something like this happens, you just set the tone for thousands of other researchers who will just pursue this branch. And until there is the next big thing, they will just pursue RL, and they will not explore maybe, because this is what happens. In transformers, the same. When transformers appeared as the next big thing, like thousands of people just research transformers, and they just maybe it would be too much to say that they're making incremental improvements, but they're just working on transformers. And to get out of this, it really needs to be huge in terms of results. To break out from this. So when he's publishing his vision, he's already using his authority to break out from this.
Yeah, that was my thought exactly now. If
authorize this direction, so to say.
Yeah, if someone else would propose this vision without authority of Yann LeCun, I think it would not get.
It would get no
attention
publicity.
Because it's a bold vision, but it's not. I think it's good. It's good.
Yeah.
The diversity in this next big things is something that, for me personally, it's good because it drives research in different direction and not only in like it's always good
it's
to have diverse.
Right? This one or this one. Yeah, this
have
kind of
diverse
gets boring.
direction.
Yes.
Yeah.
Yeah.
And maybe they will meet somewhere in a way.
Yeah.
Because
so if you weren't LeCun, if you were you or me, we would need to implement all of this, like all these modules, and again get a really like crazy result on this in order for this to be considered viable.
I think so. I think so.
Yeah.
And so, what's your personal opinion, if I may ask, on these proposals? Do you believe that you lean towards one way or the other, or you're somewhere in the middle? I don't know.
So I had this idea, which I think is quite related to what Hinton said. I thought that small children really learn fast. Okay, as I have 2 children and I've watched them learn everything, and when they learn to walk, they are restricted by their muscle capacity, so to say, because they don't have like the muscles worked out and they are not strong enough. But they really don't usually make the same mistake twice or thrice, because the negative reward is too big for them. Like they get hurt and they don't do it. So definitely it's like they explore and they just trip over like thousands of times. No. So I think this is an intuition that you get while watching children, that indeed there is something else happening. And my idea was that observation is important, and that while observing, your mind is making predictions about the next stages of the world. And then what actually happens, it either confirms your assumptions or not. And you get feedback like that. So this is what I think we do, probably all the time. And this is related to his idea of the world model. However, I do think that there might be negative feedback involved.
Okay, so
in the way that when your hypothesis is wrong, it gets denied kind of by this next stage of the world, which says, well, you were wrong.
Okay, so
this was my idea, and I kind of intuitively think it might be happening.
Okay, so to sum it all up, because it was a lot of content we covered. Reinforcement learning as the way to towards general artificial intelligence, or like better skilled AI. We covered LeCun's proposal with JEPA architecture. and had some personal opinion on
As usual.
Yeah, of course, as usual. And for me, I think it's good that we have this diversity in this big big ideas. And I like personally, I do like these huge ideas that are a bit too bold, and I think it's good it was introduced, and I think we will be coming back to this topic more than once in this podcast, because I think that is important to discuss this paths, this direction that are in front of us, to see how the research, AI research, is the landscape of our AI research now and the future maybe. So thank you very much for the conversation, and see you next time.
See you next time. Thank you.
Thank you.